Hello, Prop Stats, and welcome to 6.1. This is normal distributions. We've talked quite a bit about this, so there's not a ton that's new. So I hope you're ready to go. You will need stat disk for part of this chapter, so make sure you have that up and running in your calculator. All right, when we're talking about a normal distribution, we have to remember this. Here we go, let's make that a little bigger. Characters of a standard, like what the characteristics are, how to get to a z-score, and the probability of some range of the z-scores is what we need to know. And we're actually going to find the z-score. So we have all of this to accomplish. Some things to remember, and we already know that normal distribution is bell-shaped. And a normal distribution, and we'll talk about non-normal also, the mean is 0 and the standard deviation is 1. Always. That never changes. So now just remembering what we have here. So we have a normal distribution, we have our bell shape, and we have our mean here. Now, random variables have a distribution that graph is symmetric and bell-shaped. So we will use this sometimes to figure out what our y value is. And when we're doing that, remember this is negative and e is just a button on your calculator. Then this is x minus mu over our standard deviation squared, all over the standard deviation times the square root of 2 pi. We will probably be using stat disk most of the time. Okay. Uniform distribution, when we talk about the area under the curve, all right, it's just like always. It has to equal 1, nothing different. Remember, uniform means they are all the same across. We do not have our bell shape. And to do this, to find the area, it's the area of each rectangle, which is just width times height. So let's give this here an example. All right, a density curve is what these things are called. And a density curve is always the same, and it always has 1, just like before. Our total area is 1, which means our area corresponds to our probability. This here is always true, which we like to use. All right, now let's go to our airport data. All right, we are at JFK Airport, New York City. All right, it's a huge place if you haven't been there. Waiting times are uniform distributed with 0 minutes and 5 minutes. That means between 0 and 5, you always have the same exact average of a wait time. So our wait times are equally likely. This includes 2.3 minutes, 3, 5, 4, 8, 6, 7 minutes as 4 minutes. Nothing is different. Now the height right here is going to be 0.2. And then if I just wanted to find 1, that would be 1 times 0.2. So this area here would just be 0.2. All right, so now what we want to do is use this here and see what we can calculate. Let me erase this because I want you to shade some of this in. All right, I want to find the probability that a randomly selected passenger has a wait time of at least 2 minutes. So that means 2 minutes or more. So we go to our uniform distribution and we go 2 minutes or more. So that's everybody here. When we go through here, we know that each one of these areas is 0.2 high. So it's 0.2 times 1. So like 2 to 3, this rectangle here has an area of 0.2. This rectangle here, my drawing is terrible, also has an area of 0.2, and so does this final rectangle. So what we do is we add all of those areas up. So we have 3 times 0.2, which tells us we have a 0.6 probability of having a wait time of 2 or more. Not too bad, right? So now let's go to a standard normal distribution we've talked about before a couple of times. Now remember, in standard, that's when our mean is 0 and our standard deviation is 1 on a standard normal distribution curve, right? Density curve is equal to 1, just like before. Find the probabilities given a z-score. Now we can do this using the table A2. If you noticed, your book came with this hard cardboard thing in the front, and you can use that if you do not have stat disk handy. So when you look at the A2 for a standard normal distribution, it has a mean of 0 and a standard deviation of 1. It's the only time this table works. Okay, it's on 2 pages. If you look, you have a negative side and you have a positive side. There's a bunch of numbers on it. So down the side should go like negative 3.4, 3.3, all the way down to 0. And then your positive has the same thing. On the top, when you look at it, it has, that's a terrible curve, and then it would have like a z-score here. And then it's going to give you the area to the left is what those z-scores are going to represent. So if you picked, let's just pick the one at the very top, a negative 3.4. Now let's put another variable, a number after that, let's say 5. Okay, now if you look at a negative 3.4 on the top, it's about the first one, and then you go over to 0.05, you'll see you have an area of 0.0003. And that's how you use this thing. Or we're going to use stat disk, which is the one I like. Okay, when working, avoid confusion between the z-scores and the area. They are different. Z-scores is what we use to find the area. So the z-scores is what's on the side and the top, and the area is what's in the middle of that table. All right, they are not the same thing. All right, let's go through and see if we can actually use one of these. All right, going to do a bone density test. Now, with the bone density test, the result of the bone density test is commonly measured as a z-score. So they tell you, do you have a 2.0 or a 1.5 z-score? So are you above or below? That's what we're looking for. So the probability a person has a bone density test score less than 1.27. So I'm 1.27 or lower. That's what this graph represents. We have not found that area yet, but we do know the z-score is 1.27 and it has to be less than, so we're doing this section of the graph. Now, if you're using your A table or A2 table, you would go to z-score, you would go to 1.2, so you're on that second page. This mine's the second page. And then you're going to go down to 0.07, so you're going to find that across the top. And when those two lines intersect is the area of that curve, which is 0.8980. Now, that means 89.8% of people have a bone density levels below 1.27. Now, let's use stat disk to see how this really works. All right, so we know our z-score, this is a different one I was working on. Our z-score, I got to remember what it was now, is a 1.27. So we type that into the z-scores, you hit evaluate. Now, if you look, you'll see that you have a left and a right. So am I looking at the area on the left of 1.27 or the area on the right? And we want less than, so this area on the left. So for the z-score, you would put 0.89796. I would expect you to go out to the numbers that I give you here. All right, it's a little bit more accurate than the table, and we like that. That helps us out. So now that you know how to use stat disk, which is a lot easier, than the table, I hope you're doing well. Okay, same bone density test. I want you to type into stat disk or using your table, depending on what you have in front of you, a result of a negative 1.34. All right, if you used stat disk, you got here we go, 0.90988. All right, so this is when, here's our thing. I want to draw this so we understand what's going on. Here's our 0 for our mean. We're negative 1.27, so if this is 1, we're about right here. And result above a negative 1.27. So that's this direction on our graph. All right, so you need the right side. Now, if you did stat disk, you just typed in negative 1.27 and you used the right side. So you would have gone here, you would have typed it, negative 1.34. I want the right tail, which is the 0.90988. All right, now if you were on your table and you're looking through there, You notice that they don't give you the right, they only give you the left. So you would have to find the value of negative 1.34 and subtract that from 1 is how you would do that. So you would go 1 minus, and then 1.34, let's see if I can find it here, negative 1.34.0901. Subtract those two, and that would give you your value from the table. All right, now this is the fun part. We want to know the probability that has a result between. So now we've got here, we've got our mean, which is 0. Now we've got the negative 1.34, and we've got the positive 1.27. I want to know the value here. All right, to do this, we have to do two different calculations. On StatDisk, we would find the area to the left of 1.27. So you type in 1.27 and find the area to the left. And you should have gotten, so whoops, get a pen here so you can write. So the probability of the z-score being less than 1.27 is how that's written. Make sure you got your notation right. And we're going to say that is equal to, when I typed it in, 0.89796. Okay, pause and do your negative 1.34. Now, this time we also want less than negative 1.34. The reason is, which is 0.09012. The reason we want both negative, because we're going to take the z-score, or the probability of the 1.27, and we're going to subtract this part out. Once we do that, it's going to leave us with just this area in between, which is what we want. So we need to subtract those two. And we're going to get an area of 0.80784. And that's written the probability of the z being between negative 0.134, which is less than z, which is less than the 1.27, is equal to 0.80784. All right, I hope you did well with that. It's kind of fun. Okay, this one here is just making sure you have your notation right. This is what we just used on the other page. So this is when it's between two numbers, greater than a number, or less than a number. Make sure you are doing those correctly. Remember, stats is all about notation. All right, when you're finding a z-score from an unknown area, your first step is draw a bell-shaped curve. So I expect to see a lot of those. If that region is not accumulative from left, work instead from a known region. All right, we can do that. We're going to use technology. We're going to use StatDisk. You can use A2 if you're at home to find the z-score and identify what we're looking for. Critical values. A critical value is a z-score on the borderline, all right, separating z-scores that are significantly low or significantly high. Remember, those are 2 or more standard deviations from the mean. Another notation, whenever you see z sub a or alpha, this is telling you that it is the area to the right. It is not the area to the left, so be careful. This is alpha is to the right, not left. So when we see this, we have z of 0.025. I want to know the area, that's the area to the right of the z-score, and then I have to calculate the z-score. Okay, in order to do this, because if we type in 0.025 in our StatDisk, watch what happens. Let's just do that real quick. So now that we're given a cumulative area, not the z-score, we type this down here in the area, and we get 0.025. And that tells us my z-score is a negative 1.95996. The reason this is happening is when we do this, it is giving you this area here. All right, that is how our probability statistics StatDisk works. So in order to get the area to the right of 0.025, I have to go down here and say I want 1 minus that, so I switch where I am. So I'm going to do 1 minus 0.025. All right, and that's going to be equal to 9.75. Now, oh, sorry, I wrote that wrong. That's 0.975. Maybe, if it will erase for me. There you go, 0.975. Now when we type this into our stats disk, it's going to give us the area that we need, because now we got 1.95996 when you look at the area of our graph. So 0.9996 is what this area is through here. All of this is represented by that, which gives us the 0.025 over here. So since I'm given the right, stat disk is going to find the left, so we need to subtract this one. Then our z-score that we got. Now remember, you are in stat disk, so you can go out a little farther. And it should be 1.95996. Much more accurate than the table. All right, good luck. I hope you do a good job, and make sure you post questions if you have any.